So this is what I just talked about. That's what we call aliasing. So symbols can alias other things. So tuples, okay. So remember I said tuples, they're like lists, but the big difference is they're immutable. Why would we want to use tuples? Well, let's go ahead and do a couple tuple examples. So we have A equals. So A is now a tuple of those three things. We access items, we slice items, we do everything in a tuple exactly like how we do lists. But there are a couple advantages and a couple disadvantages. So in tuples, they tend to be more, they use less memory, they perform better than lists, which you don't really have to worry about it too much. But the big thing we can do is we can use tuples to flip things around. So if we do something like A equals 1, oops. Okay. So we have, I went ahead and made four variables here, A, B, C, and D. So if I wanted to flip these around, what I can do with it, if I wanted to swap, let's say I wanted to swap A and B. So I can do A, B. Okay. What I can do is this, A comma B equals B comma A. Okay. Swap. Okay. If we didn't have tuples, we would have to create a little temporary variable and then copy one and then do the swap and then put it here. But tuples are a nice way of flipping things around. Frequently, we'll have variables that return a tuple, and then you can use a syntax like A comma B comma C equals the stuff. And then this is kind of a more you really probably wouldn't really encounter this. I'm just making you aware of it. But the thing is tuples cannot be modified. So A equals A. Doesn't support assignment. So they're a convenient way of doing swaps or these sort of repermuting the order of things, convenient way of doing things. We can, yeah, like I said, we can iterate. Iterating over tuples is completely and totally identical to iterating over lists. No difference at all. So you have square brackets, elements, lists are mutable. Okay, so we did. So we already should be pretty good at indexing, grabbing, and setting individual values of lists. So lists, they're mutable. We iterate over them. So okay, do something, and then you guys are really good experts at concatenation. So a couple other methods that the list has on it. we can do remove. Let us yeah, you can actually alter elements in lists. So let's go ahead and do A equals list range. We got a nice little handy list there. So we can so just like append adds an element, removes an element. So A dot remove 3. So we've removed the that actual object out of there. You can also remove objects by index if you wanted to. And this is just something you have to get used to. I mean, Python, sometimes things are available as a method. So you have a dot tab. These are the methods that are in the index to, oops. Give you back a number, okay. So many things are available as methods on the object, but certain other things are available as separate functions. And so things like len, the length of it, that's a separate function. Unfortunately, we don't have an a.len. Doesn't exist. It's just the way things are. So the two things, so most of the time, most operations are a method on the object. A couple separate ones like len and del, delete, those are outside, those are standalone functions. Okay? So if we wanted to remove an object in a list by index, so we have A, and let's go ahead and remove the one there. So we can do del A 1. So that mutates list, that removed that actual element from it. Pop, we have A dot okay. Pop removes the last element in the list. So that's it's sort of a convenient way of using the list as a stack. You can grab the first one or the last one. Okay. So we can convert between strings and lists. Okay, so we had a string here. S equals, well, that's a string. So now we can do SL equals list. So that took all the characters out of that string and it made it into a list. So now that's a list. We have a little funny way of combining lists. So if we just try to do a stir on this list, show what happens. Okay. So that does a funny thing in making it, that's not what you want. What you want is, this will be a little bit funny, but if we make a string And if you use dot, that'll be tab, join. Okay. So strings have a variety of methods on them. One of those methods is join. And this is one of the little quirky things in Python where strings are, they're not treated exactly the same as lists. There are a couple little subtle differences in what methods they have on them. And that's just something I just recommend just looking at the cheat sheet of what are the methods available on the string, what are the methods available on a list, because they are slightly different. Okay. I can do a fun little thing like underscore join. Okay. If you take any string and you join it with a list, it'll what's called interleave them. It can frequently be something useful to do. No, I just you honestly won't really be working with strings much. I'm just making you. I'm just showing you just so you would be aware of the fact that strings are slightly different than lists. So we can lists also have methods on them called sort and reverse. Reverse. Okay. So we have SL. That's a list of characters. You can do sorted. L. Okay. Well, that doesn't do much. So L equals. Let's do random order. Okay. So sorted. What sorted does is that creates a new list that is the original list that's sorted. So sorted, it did not modify L itself, but it created a new list of all those elements that are in sorted order. You can actually go on the list itself and sort that one in place. So now L itself is sorted. You can reverse it in place. Okay. So, and in the Jupyter Notebook, to get a list of all of the methods that are on an object, you simply press dot and then tab. And then that brings up a pop-up box showing all these little methods on here. And then most of the time, their name it's obvious what it does. So you have obvious that copy makes it copy, inserts an element, so forth. Many times they're not obvious. So they're just look at the documentation on the Python cheat sheet. Okay, so aliases. I went over this a little bit. So this is where, like I said, names are subtly different than variables, and like I said, that's why I don't like using the term variables here. But it's just something to be aware of when you make two names and you make a list or some other composite object, those names both refer to the same thing. If you want them to be an actual copy, you have to call the copy method on the list. Clone it, sort it. Okay. Lists are really powerful. Lists can contain lists. In fact, any item in a list is an object. And that item, it can be a number, it can be a string, it can be another list, it can be a dictionary, it can be any other kind of object. So lists are what are called heterogeneous containers, meaning that they can contain different kinds of objects. When you are iterating over a list, you never want to try and modify the list of things you're iterating over. So if we're doing something like for E and L1, L1.remove, okay? So we're calling a method that mutates an object that we're iterating over. That causes undefined behavior. It will generally give you unexpected results. So don't do that. If whatever you're modifying, it has to be different than the thing that you're iterating over. So that's just one little gotcha there. Not gotcha, just something to be aware of.